Hello, hi guys. So in this video, I'm going to talk about 2.3, which is capacitors with dielectric. Okay, so dielectric is basically just a piece of anything that is made of any kind of material. So it can be platinum, aluminium, copper, copper, or whatsoever lah. So basically, in dielectric, it has for example, it's a sheet of paper. Okay, and it has free charges. Free charges is as in like this. So kita ada free charges. So it's randomly arranged charges. So dia ada plus, minus, plus, minus. It's a balance charges, but tak ada the natural kan. So that is not aligned. Okay, so basically dalam dielectric, free oriented charges. Okay. Right. So bila kita ada capacitor, so when we're talking about capacitor, so capacitor, it has a parallel plate. Okay, capacitor is a parallel plate. For example, like this. Capacitor. So kita sikit. Okay. So when your capacitor is connected to a power supply, so what happen is, so the one plate will be, for example, this will be positive plate, this will be negative plate. Okay. So when the both plates are charged, so what happen in between here, there will be electric field. Okay, so basically this is coming from 1 point something lah, dekat chapter 1. So kita ada electric field in between these two plates. Yang ini adalah ni awal-awal lah. So dalam kat sini adalah air ataupun vacuum. Okay, so bear in mind the things that we are talking now is a parallel plate with air field. Okay, so the system here, the capacitor is disconnected from a battery. So saya tulis note kat sini, capacitor disconnect from battery. How is that significant? So when the capacitor is disconnected from a battery, means that Q is constant. Okay, the charge cannot go anywhere. So the total charge of the system will be constant, which is Q with dielectric. Q naught is the same thing as Q. Okay, Q naught is charge without dielectric. Q will be charged with dielectric. Right. So we can see here, we have a capacitor, parallel plate, positive, negative, then we have electric field. So as I said before, dielectric is a piece of anything, any kind of material that has a free charges that is not oriented. So what happen is, when we put in the charges, the dielectric in between here, for example, we put the dielectric here. Kita letak dielectric. Okay. Kita letak dielectric dekat sini. Okay, tadi mula-mula awak tengok dekat sini, dia punya charges randomly arranged. Tapi dia natural lah. So kalau natural tu, dia tak ada satu kiri negatif, satu kiri kanan. Tak. Okay, so there is free oriented charges. So bila kita masukkan dielectric ni in between the parallel plates, what happen to the free charges tu? Free charges tu akan tersusun cantik. Tersusun maksudnya macam mana? Tersusun maksudnya, kalau tadi dia merata-rata, sekarang ni dia akan jadi macam ni. Saya lukiskan kejap. Okay, tadi dia free, sekarang dia tersusun. So apa yang jadi, ni kan positif. So all the charges dekat belah sini yang dia kena dengan positif akan jadi negatif. So ni akan jadi negatif, positif, negatif, positif, negatif, positif, negatif, positif. So belah sini akan jadi negatif, positif, negatif, positif, negatif, positif, negatif dan juga positif. So, tadi tak ada apa-apa je dekat elektrik. So, now dia punya charges dalam ni dah tersusun dengan cantik. Positif will be attracted to negative part. So, ni positif tertarik dan sebagainya. So, in between this dielectric, dalam dielectric ini sendiri akan terhasillah electric field. Okay. So, dia akan terhasil electric field sendiri yang dalam ni. Supaya kita katalah dia punya electric field yang terhasil, jadikan dia orange. So, positif ke negatif sini. Sama-sama color. So, positif ni basically is reverse electric field yang terhasil due to parallel plate. Okay. So, kalau tengok sini, dalam dielectric ni, satu ke kanan, satu ke kiri. So, what happen is basically, dia dah cancel out. The electric field in the dielectric cancel out the electric field produced by the parallel plate. So, kalau kita kata, kita boleh padam kat sini. So, kita boleh padam electric field dalam tu. Sebab apa dia terpadam? Sebab dia tercancel out due to the electric field produced within the dielectric. Okay, so kalau dalam chapter 1, we talk about how electric field is defined by the strength of electric field is defined by how many lines represent it. So kalau kita tengok dekat sini, tadi awal-awal dia ada berapa? 1, 2, 3, 4, 5, 6, 7, 8. Initially dia punya electric field ada 8 lines. So now when we put in the dielectric, sum of the electric field is cancelled. So we are left with 1, 2, 3, and 4. So as the line of electric field decreasing, means that the strength of electric field also decrease. Okay, faham tak? Means that apa effect? Effect of dielectric. Of the electric, first kali, electric field decreases. Okay, so we put some notation. So value without dielectric, kita akan notekan semua benda yang without dielectric sebagai E0, V0, C0. Okay. So these are the value without dielectric lah. So if you see something with not here, means that the value is without dielectric. Okay, so with the dielectric, so when we inserted the dielectric, kita dekat sini. Okay, so as we know that before, when we put in the dielectric, the electric field will decreases. Okay, in comparison, means that E will be less than E0. Electric field with dielectric will be less than electric field without the dielectric. Okay, so kita ada equation V equal to ED. Okay, as we didn't do anything to the separation between the plates, so ini adalah constant. So as that is constant, V is directly proportional with E. So electric field with the dielectric is decreasing. So as E decreases, therefore the potential difference between the plate also decreases. How does this affect the capacitance? So kita ada Q equal to CV. Okay, as a reminder again, so your Q will be constant. Why is it constant? Sebab this is disconnect with the battery isolated system. So from there, C is inversely proportional with the potential difference. As the potential difference decreases, the capacitance also increases. So, from here we can conclude that. Conclusion. Okay, with the dielectric, the electric field will decreases, potential difference between the charges decreases, and therefore the capacitance of the capacitor will increases. Okay, how about the calculation? So, without the dielectric, without dielectric, we can calculate that C naught equals to epsilon naught A over D. Means that the value of capacitance can only be changed with the changes in surface area of the capacitor, of the plates, and also the separation between the plates. Okay, sebab satu lagi, kalau kita ada capacitor dekat kepala dah tulis lah, katalah 5 microfarad. Means that if we change potential difference ke, charge ke, whatsoever, capacitance masih lagi 5 microfarad. Okay, unless we do something with the area and also separation between the plates. Okay, so this is C naught equal to epsilon naught A over D. Okay, then kalau kita kata with the dielectric, equation will be C equal to epsilon naught A over D. Okay, epsilon R ni adalah dielectric constant. It depends on the material of the dielectric. Okay, and has no unit. Right? So, kita boleh kata dekat sini, so yang belakang ni kan sama dengan ni. So you can say that C equal to epsilon R C naught. Capacitance with the dielectric, kita just kalikan saja capacitance without dielectric dengan dielectric constant. Right? So, ataupun kita boleh tuliskan sebagai ni, sometimes dalam equation dia bagi C equal to epsilon A over D. So, epsilon ni awak kena ingat, this one, epsilon ni adalah epsilon sama dengan epsilon R epsilon naught. So, how do we define dielectric constant? Equal to epsilon over epsilon naught. Okay, what is epsilon? Epsilon R is dielectric constant. Okay, epsilon adalah permittivity of the dielectric material. Whereas epsilon naught is permittivity of a free space. Free space. Sebab we are basically is without dielectric, we assume that within the parallel plates tu kita ada air ataupun vacuum lah. Okay. So kalau tak pun epsilon R dielectric constant tu air adalah 1. Okay, so apa lagi? Itu sahajalah. Itu dielectric constant. So any other calculation will be the same lah as 2.1.